Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so let's continue on estimation. Okay, so we are still on to find the estimation between the difference between two population mean, but we will continue on the other two cases. Okay, case number 3 in case number 4. Okay, so basically the case number 3, before that I repeat back our first two case is we are given the value of population variance or population standard deviation. Okay, and we assume that our sample size are large. Okay, and then number 2, we does not know what are the population variance or population standard deviation, and then still the sample size are greater than 30. Okay, so both of the first two cases we use Z. Okay, now you want to look into when population variance or population standard deviation are unknown. Okay, so I will highlight the word unknown. Okay, variance or standard deviation are unknown, and then we assume they are not equal. Okay, and the other one, the sample size both are less than 30. So here 30 less than 30, we consider the sample size are small. Okay, so what are the formula? The formula is given by x bar 1 minus x bar 2 plus minus t alpha over 2 degree of freedom times square root s1 square over n1 plus s2 square over n2, where the formula of degree of freedom is given by this formula: s1 square over n1 plus s2 square over n2 squared divided by s1 square over n1 square over n1 minus 1 plus s2 square over n2 square divided by n2 minus 1. Okay, and then you need to truncate, okay, the degree of freedom value to the lowest value. For example, if you get 18.75, so we truncate the value into 18. Okay, or if you get 18.3, still we truncate into the lowest value, which is 18. Okay, so ingat ya, if you get, okay, the point is more than 0.5, for example 19.5, still we truncate into the lowest value, which is 18. Okay, so here why we use t? Okay, because of this, we have the small sample size. The first two cases we use Z. Okay, because the case number 1, we know the population variance or population standard deviation, and for the case number 2, we have large sample size, n1 n2 greater than 30. Okay, but for the case number 3, since we have n very small and we does not know the population variance or population standard deviation, that's why we will use t. Okay, but for case number 3, we assume the variance are not equal. Okay, but for case number 4, okay, still the population variance or population standard deviation unknown, but we assume it was equal. Okay, and the last one, the n should be small also, less than 30. So what are the formula? The formula is x bar 1 minus x bar 2 plus minus t alpha over 2 degree of freedom n1 plus n2 minus 2, and then we times sp times square root 1 over n1 plus 1 over n2, whereby the SP is given by n1 minus 1 s1 square plus n2 minus 1 s2 square over n1 plus n2 minus 2. Don't forget to square root the value of pool standard deviation. Okay, for case number 4, okay, for case number 4, why we use t? Okay, this is the reason, because our n is small. Okay, but since the variance are we assume equal, that's why we have to find the pool standard deviation. Okay, when you are given the information that their variance are equal, okay, the variance of the two population are equal, then we have to find the pool standard deviation first. Okay, let's take a look into the example. Okay, before that, let's see what are the assumption for case number 3. One or both sample size are less than 30. Okay, population are normally distributed. Population standard deviation sigma 1 and sigma 2 are not known, but the standard deviations are assumed to be different. Okay, the variance are not equal. Okay, so case number 1 and number 2 we use Z, and then case number 3 and number 4 we're going to use T. Okay, again I repeat the formula for the confidence interval between the difference between population 1 and population 2 is given by x bar 1 minus x bar 2 plus minus t alpha over 2 degree of freedoms time s1 square over n1 plus s2 square over n2 square root, whereby the value of degree of freedom is given by this formula. Okay, note that don't forget to truncate the answer to the lower value for the degree of freedoms. Okay, example 3.14. The breaking strength of 11 bundles of wool fiber have a sample mean 436.5 and sample standard deviation of 11.9. Okay, in addition, the breaking strength of another 12 bundle of synthetic fiber have a sample mean 452.8 and sample standard deviation of 4.61. Assume the breaking strength of the two populations are normally distributed with unequal variance. Okay, so you need to construct 95% confidence interval on the mean difference of breaking strength between wool fiber and synthetic fiber. Explain your answer. Okay, let's figure out what are the information given to you. Okay, so first we have information on the wool fiber. Okay, so we have n equals to 11. Okay, these are the n1. Okay, and then we have sample mean. Okay, sample mean for 11 of wool fiber, we have this one is this one is x bar 1. Okay, for 36.5 and sample standard deviation of 11.9. Sample standard deviation, so this one is our S1 squared. Sample standard deviation is S lah. Okay, now we have another population which referring to the synthetic fiber. Okay, so we have n equals to 12. Okay, so this one is n2. And then their sample mean is 452.8. So this one is x bar 2. And the sample standard deviation is 4.61. So this one is our S2. And the other important information here, we are told that okay, the variance are unequal. Okay, so we can write the information. first we have wool, and then the one we have synthetic. Okay, and 1 equals to 11 and 2 equals to 12. X bar 1 equals to 436.5. X bar 2 equals to 452.8. S1 equals to 11.9. S2 equals to 4.61. Okay, so what should we do is, since we know that the variance are assumes unequal, okay, so what should we do? We need to find the value of degree of freedom first. So our DF equals to 11.9. Okay, don't forget to put square because 11.9 is standard deviation. So based on the formula, it was S1 square, which is variance. So don't forget to put square. Okay, so 11.9 square over 11 plus 4.61 square over 12. Okay, then you have to square the whole thing. Okay, and then divide by 11.9 square over 11 square over, and 1 minus 1 is 10. Okay, and then plus 4.61 square over 12 square over, and 2 minus 1 is 11. So finally we will get the answer is 12.72, which is we need to truncate into the lowest value, which is equivalent to 12. Okay, so our alpha here is 0.05. Okay, so we need to find T alpha over 2 is T 0.025 with degree of freedom that we have calculated just now, which is 12. So you need to refer table 7. We will get the value of T, or the value of a critical value. So this is called critical value is 2.179. Okay, so we substitute into the formula. Okay, so substitute into this formula. Finally we will get, okay, so this is the confidence interval, 436.5 minus 452.8, okay, plus minus 2.179 times, okay, saya sambung kat bawah times 11.9 square over 11 plus 4.61 square over 12. Okay, so finally the answer is equivalent to negative 24.639 and 7.961. Okay, before I forget, so this part, okay, this part is critical value. We call it as critical value. And this part is error or standard error. Okay, we already have or calculate the confidence interval. So what can we conclude here? So look at the interval. So we can say that the the zero value has been passed through by the confidence interval. Okay, so we can conclude that there is no difference of breaking strength between wool fiber and synthetic fiber since the confidence interval include zero value. So that is how we explain your answer. Now let's proceed into example 3.15. Okay, a field economy study was conducted for two automobiles, Marcel and Vaux. One vehicle of each brand has been selected and the mileage performance was observed for 11 tanks of fuel in each car. Okay, so meaning that Marcel 11, Vaux also 11. The statistic of data collected in miles per gallon are as follows. Okay, the X bar for Marcel is 24.67 and the variance is 1.08. For Vaux, mean 41.21 and the variance is 1.36. Okay, assuming the population variance are unequal, okay, we assume population variance are unequal, find a 95% confidence interval for the difference in mean mileage performance between Marcel and Vaux. Okay, so we since we does not know the population variance or population standard deviation, and then we only have 11 okay tanks of fuel for each car, meaning that our n is small. Okay, so that's mean we should use T. Okay, and then the other one, the assumption was told that the population variance are unequal, so that's why it's fall under case number 3. Okay, so what should we do? First, we need to find the value of degree of freedom first. So our degree of freedom equals to 1.08 over 11. So we don't have to square the value of variance because it's already in square. Dia dah memang bagi value variance which is S square. So kita tak perlu kuasa duakan dia. Unless if you are given the value of standard deviation, then you need to put square. So this one is 1.08 over 11 plus 1.36 over 11. Okay, and then we need to square. Okay, and then this one is 1.08 over 11 square over 11 minus 1 is 10 plus 1.36 over 11 square over 10. So finally we get the degree of freedom is 19.76. So we truncate the value, it will become 19. Okay, so our alpha is 0.05. So T alpha over 2, 0.025 with degree of freedom 19 will be equivalent to 2.093. So refer table 7. Okay, now we will calculate the value of 95% confidence interval. Okay, so it was equals to 24.67 minus 41.21 plus minus the critical value is 2.093 times 1.08 over 11 plus 1.36 over 11. Okay, so finally the answer is negative 17.526 and negative 15.554. Okay, so how we conclude this confidence interval? Okay, look at the confidence interval. This one negative 17.5, negative 15.5. So 0 was not in the confidence interval. So we can conclude that since the interval does not contain 0, there is difference. There is difference in mean mileage. Between Mersenne and Vogt. So kita boleh kata since the interval does not contain 0 value, there is difference in mean mileage between Mersenne and Vogt. Okay, another things that we can see here, since the interval are negative, okay, meaning that m minus v less than 0. So it means that Mersenne was less than Vogt. Okay, so another things that you can discover here is mean mileage performance of Mersenne is less than mean mileage performance of Vogt, because Mersenne minus Vogt we get negative value, so that's why we can conclude that mean mileage performance of Mersenne is less than Vogt. Okay, beside that, if you see roughly here, the value of x bar of Mersenne is clearly small than the value of mean for Vogt. Okay, but we need to confirm by calculating the confidence interval. So it was confirmed that mean mileage of Mersenne is less than mean mileage of Vogt. Okay, next example, 3.16. A set of facilitation tools to help with data analysis for problem solving is being developed by a group of statisticians at UiTM. In order to test effectiveness of this tool, a group of research officers were asked to analyze and produce built-in report for a set of data on the computer. 12 equally capable research officers were randomly selected, and 6 were randomly assigned a standard procedure. The other 6 were asked to do the task using the developed facilitation tools. The response measure was the time to completion in minutes, and the data collected are shown below. So we have group 1 and group 2. Group 1 were tested using standard procedure, and group 2 were tested using the facilitation tools developed. Okay, so what has been measured was the time to complete. Okay, so you can see here all the value of the time to complete for both group. Okay, assume that the population variance of the two procedures are different. A miniature output is shown below. Okay, so this will call as a miniature output. Okay, miniature output is one of the statistical software, okay, that can be used to analyze our data. Okay, so what are the information given here? So we have value n for both groups. So group 1 we have 6, group 2 we have 6 also. The mean value is 65.5 for group 1, and for group 2 36.5, and their respective standard deviation and standard error mean. Okay, so to confirm how we get the standard error mean. Okay, so standard error mean can be found by dividing the standard deviation value over square root n. Okay, so you can check this value 2.4 are we can get the value of standard error mean by dividing 5.89 over square root 6. Also, same for group 2. Standard error mean is calculated by dividing the value of standard deviation over square root and 4.09 over square root 6, we get 1.7. Okay, so another input here, the difference, okay, group 1 minus group 2. So what has been calculated is the difference between group 1 minus group 2, okay, not group 2 minus group 1. So the estimate for the difference, meaning that x bar 1 minus x bar 2, we get 29. So this is calculated by 65.5 minus 36.5. That's why we get 29. So you are given the value of 99% confidence interval for the difference. Okay, it's given by 19.1792 and 38.8208. Okay, so what are the question here? Okay, the question here, state the confidence level used in this test. Okay, show that the degree of freedom is 8. Okay, and then can you conclude that the facilitation tools increase the speed at which the task is completed by more than 20 minutes? Okay, so the confidence level for question A, okay, the confidence level used here is 99%. Okay, it has been stated here. Okay, and then for B, show that the degree of freedom is 8. Okay, so recall back, formula for degree of freedom equals to S1 square. Okay, so 5.89 square over 6 plus 4.09 square over 6 square over 5.89 over 6 over n minus 1 is 5 plus 4.09 square over 6 square over 5. So we get the answer is 8.912. So we truncate into the lowest value. It was equivalent to 8. So it was proven that degree of freedom equals to 8. Okay, and then for C, can you conclude that the facilitation tools increase the speed? Okay, so from the output, the 99% of the interval for the difference is equivalent to 19.1792 and 38.8208. Okay, so what can we conclude here? Since the interval is positive, which is between 19.1792 and 38.8208, it shows that the facilitation tools increase the speed at which the task is completed by more than 20 minutes. Okay, why we can say that? Okay, so if you look at the interval, okay, interval is 19.1792 and 38.8208. So meaning that we can say that, okay, group 1 minus group 2, we get the value positive, greater than 2. So we can say that group 1 time for group 1 is more than time for group 2. So why we set increase? Okay, in term of time, okay, lagi laju dia lagi speed up lah, betul tak? Okay, so kalau time group 1 lagi lama dari lagi besar daripada group 2, maksudnya group 1 lagi lama daripada group 2. The group 1 taking longer time than group 2. Okay, so kalau waktu dia sedikit, maksudnya the speed was increased lah. So since we get that the confident interval were positive, okay, positive meaning that group 1 is larger than group 2. Okay, so we can say that the facilitation tools increase the speed because we get confident value the positive. But if you get the value are negative, maksudnya value kecil tolak besar, that's why kita dapat negatif. Okay, yang ni value besar tolak kecil, group 1 lagi besar daripada group 2. So that's why kita dapat value hasil tolak dia positif. Tapi in term of time, kalau lagi sikit, lagi kecil value waktu dia tu, maksudnya dia lagi laju lah. That's why kita kata the speed was increased. Okay, let's continue into next cases. Okay, next cases is population variance are not known. Okay, but we assume it was equal. Sigma 1 square or equal sigma 2 square. So let's click into the assumption. Population should normal and small sample less than 30. Standard deviation are not known, but we assume it was equal. So the confidence interval is given by x bar 1 minus x bar 2 plus minus t alpha over 2 time, okay, pull standard deviation time 1 over n1 plus 1 over n2 square root. And then the degree of freedom is given by n1 plus n2 minus 2. But we need to calculate first the value of pull standard deviation. This is given by n1 minus 1 times s1 square plus n2 minus 1 times s2 square over n1 plus n2 minus 2. Okay, example 3.17. An insurance company wants to know if the average speed at which man drive car is greater than woman driver. The company took a random sample of 26 cars driven by men and found that the mean speed to be 72 miles per hour with standard deviation of 2.2. Another sample of 16 cars driven by women on the same highway give a mean speed of 68 miles per hour with standard deviation of 2.5 miles per hour. Assume that the speed at which all men and all women drive car on this highway are both normally distributed with the same population standard deviation. So construct a 98% confidence interval for the difference between the mean speed of car driven by all men and all women on this highway. Okay, so this example is regarding the average speed between man driver and woman driver. Okay, so let's figure out what are the information we have. So we have man and woman driver. So man and one kita ada sample of 26. Okay, we found that the average speed or the mean speed x bar 1 equals to 72 and the standard deviation s1 equals to 2.2. And then for women, we have n2 equals to 16, x bar 2 equals to 68, and s2 equals to 2.5. Okay, so since it was stated here, the population standard deviation are normally distributed with the same population standard deviation. So meaning that sigma 1 equals to sigma 2. Okay, so value of alpha here is alpha equals to 0.02. Okay, so since dia dah kata the population standard deviation are equal, so we will use case number 4. Okay, so first we need to find the value of SP lah, for pool standard deviation. So the formula is given by N1 minus 1. So N1 we have 25 minus 1 times S1 square, 2.2 square. Jangan lupa letak kuasa 2 sebab value yang 2.2 adalah value standard deviation. Okay, dekat formula dia adalah value variance, so you need to put square. Okay, plus N2 minus 1, 16 minus 1 times 2.5 square, divide by N1 plus N2 minus 2, 26 minus 16 minus 2. Don't forget to square root the whole thing. So finally we get the pool standard deviation is 2.317. Now we can you can find the critical value first. Okay, so our critical value is T alpha over 2, 0.02 divided by 2 is 0.01, and then the degree of freedom is N1 plus N2 minus 2. Okay, this one. So untuk yang case variance are equal, dia punya degree of freedom dia adalah N1 plus N2 minus 2. So 26 minus 6, 26, sorry, this one is plus. Okay, 26 plus 16 minus 2, we get the value of degree of freedom is 40. So look at table 7, we get the value of critical value is 2.423. So finally you can plug in into the formula. So x bar 1 minus x bar 2, 72 minus 68 plus minus T alpha over 2 df is 2.423 times dengan darab dengan, okay, SP 2.317 times 1 over N1, 1 over 26 plus 1 over 16. Okay, so finally the answer is 2.216 and 5.784. Okay, don't forget, please solve the minus sign first, then baru plus. Okay, so your answer will be 2.216 and 5.784. Okay, so if you are asking to interpret this interval, what can you say? So we can say that since the interval are positive, okay, so meaning that the speed of man driver is greater than speed of woman driver. Okay, so meaning that, maksud dia kat sini average speed by man driver is, maksudnya man is greater than woman. Okay, so meaning that man driver dia punya speed dia lagi tinggi daripada woman driver. Okay, since bila kita tolakkan average man minus average woman, kita dapat kalau dia punya confidence interval dia positif. So maksudnya value yang besar tolak value yang kecil. So speed of man greater than speed of women. Okay, so ayat yang lengkap dia adalah, okay, the 98% confidence interval for the difference between the mean speed of car driven by man and woman is equals to 2.216 and 5.784. Okay, meaning that man driver speed is greater than woman driver, speed. Okay, so in terms of speed, man is greater than woman. Okay, let's continue into example 3.18. A private hospital installed a new piece of equipment to replace an aging one in the hope that it will speed up the treatment of patient. The treatment times of random sample of patient using the old one and new equipment were recorded. Okay, the summary result in minutes were, so we have two population here referring to new equipment and old equipment. Okay, so all these are the information regarding the two population. Okay, new and old equipment. Assuming the population variance are equal, construct a 95% confidence interval to estimate the true difference in mean treatment times using the new and old equipment. Okay, so dia dah kata population variance are equal. So what we need to do, first we need to find the value of SP. Okay, so our SP here equals to N1 minus 1. Okay, so 9 minus 1 times S1 square. S1 square is 14.5. So kita tak perlu letak kuasa 2 sebab ni dah memang variant. Variant dia punya notation dia S square. Okay, so tak perlu letak kuasa 2. Tambah dengan N2 minus 1. 10 minus 1 darab dengan 8.2. Okay, over 9 plus 10 minus 2. Don't forget to put square root. So finally the answer for the full standard deviation is 3.341. Okay, now we find the value of alpha. So our alpha is equals to 0.05. So T alpha over 2 is 0.025. And then our degree of freedom is 9 plus 10 minus 2. We get 17. Okay, refer table number 7. We get the critical value is 2.110. Okay, so you just plug it into the formula of confidence interval. We get x bar 1 minus x bar 2. 26 minus 22.5 plus minus critical value tadi kita dapat 2.110. Okay, darab dengan SP 3.341 times 1 over 9 plus 1 over 10. So finally we get the answer is 0.261 and 6.739. Okay, so you can see here the interval does not passing through the zero value. Okay, so since the confidence interval does not contain zero value, so there is difference between the time taken by new equipment and old equipment to treat the patient. Okay, so there is different. Ada different antara new equipment and old equipment. Tapi nak tahu mana satu yang lagi lama ambil masa. Okay, since kita buat new minus old, so kita dapat positive value, meaning that time taken by new equipment is greater than old equipment. So sekarang ni time taken by new equipment is longer than old equipment. Maksudnya the equipment does not speed up the time taken to treating the patient sebab confidence interval kita positif. Okay, meaning that time for new equipment is longer than time for old equipment. Okay, let's look into example 3.19. The manufacturer of small battery power tape recorder decide to include 4 alkaline battery with its product. 2 battery suppliers are being considered. Each has its own brand 1 and brand 2. The supervising inspector of incoming quality want to know if the average lifetime of the two brands are same. Based on the past experience, she believed that the battery lifetime follow a normal distribution with equal variance. A sample experiment is conducted. Each of 10 battery, okay, 5 for each brand, so brand 1 ada 5, brand 2 ada 5, is connected to a test device that places a small drain on the battery power and record the battery lifetime. The following results are obtained. So again, you are given the Minitab output. Okay, so we have information on brand 1 and brand 2, the value for their mean, standard deviation and standard error mean. Okay, so apa yang dia buat, dia cari difference between brand 1 minus brand 2. So the difference is 12.6. Okay, this is calculated by 44.2 minus 31.6, so we get 12.6. So 95% confidence interval for the difference are not given to you, so meaning that we need to find by our own. Okay, but you are given the value of you are already given the value of pool standard deviation, which is this one is our SP. Okay, so tak perlu calculate dah. So now we want to construct 95% confidence interval on the difference between the average lifetime of the two brands. Okay, so we just apply the formula. Okay, we already have the value of SP. Identify the value of alpha, so our alpha is 5%, 0.05. So T 0.05 divided by 2 is 0.025. So our degree of freedom is 5 plus 5 minus 2 equals to 8. And then refer table, we get 2.306. SP is given to you 4.7434. So x bar 1 minus x bar 2, 44.2 minus 31.6 plus minus T alpha over 2 DF is 2.306. Okay, darab dengan SP 4.7434, 1 over 5 plus 1 over 5. Finally, we get the answer is 5.684 and 19.516. Okay, so what can we conclude here? So we can conclude here the average lifetime of the two brands are not equal. Why not equal? Because the interval is positive ataupun does not passing through 0. Okay, so meaning that brand 1 minus brand 2, kita dapat value dia positif greater than 0. So meaning that brand 1 is greater than brand 2 in term of the average lifetimes. Okay, so dia does not equal dia punya lifetime sebab confidence interval dia does not contain 0 value. In fact, we can see here brand 1 is greater than brand 2 dia punya lifetime. So again, please look back this note on how to interpret the interval value. So kita ada 3 jenis interval lah, sama ada interval value tu plus plus maksudnya positif, ataupun negatif ataupun plus minus. So kalau plus plus maksudnya dia tak lalu kosong lah. So dia adalah bermaksud there is different. Kalau negatif pun sama, there is different. But kalau awak punya interval plus minus, so dia bermaksud no difference sebab dia mesti lalu kosong.